All right, guys, welcome to Algebra 2. This is 213, and we're going to be talking about parabolas and how we can graph them straight from the equations which we get. So, to start off, I'm going to have you guys go ahead and go to this link here. It's a short link that will take you to a Desmos program. So go ahead and pause and open up that. And then once you have that open, what I want you to do there is try and answer these questions, right? So how can you cause the graph to be stretched vertically? How can you cause the graph to be flipped vertically? How can you cause the graph to shift left and right? And how can you cause the graph to shift up and down? So go ahead and pause the video and try that out and see what you can do, and then come back here. All right, so if we look at Desmos here, we're seeing on these, so we have a general parabola, so they're going to leave this blue graph there as your kind of starting point, so that's the default. So if the A value, which is the number in front here, if I make that larger, we're seeing that I'm stretching my graph vertically, and if I make it smaller, so when I'm less than 1, I'm going to start to get really, really wide, right? Then as soon as I get that A value to be a negative, I flip it, and now I'm going downwards. And then the same thing kind of follows there. So there's my A value changing there. So H, which is the number here on the inside with that X, if I make this H larger, so now it's X like -2, I move to the right 2, make it H like a -3, so now it's be X minus a -3 or X plus 3. And I'm going to be moving left 3. So we can move with left and right with the H, right? And then the K value, which is the number here on the outside, if I increase that, I go up. If I decrease it, I end up going down. So those are the main things that we want to be able to kind of do and see have happen here with our general form. So we have the A, the H, and K. Those are called parameters, which are basically the numbers in the form of an equation that are going to be changing. So like in this form of a parabola graph, the y is always there, the x is always there. Those are our variables. The a, the h, and the k, those numbers which are different for every single parabola, those are what are called our parameters. So hopping back over here, what we want to take a look at next is once we've kind of figured that out, we should be able to get to the point where we can look at an equation like this and know exactly what that graph is going to look like. So what I want you to do is go ahead and pause the video, look at these equations here, and without graphing them, say what it's going to look like. Say, hey, it's gone right 2 and up 1, and it's getting wider, stuff like that. So go ahead and pause and do that. All right, so A here, this +9 is going to actually move us to the left 9, because remember it's x minus a -9, which means we're going to go left over to -9. Here on B, that 7 is going to move us up 7. C on C, the 3 is going to actually make our graph a lot more narrow. It's called a vertical stretch. On D, I have 1/3 there. That 1/3 is going to actually make it wider, so it's going to be a vertical compression, so it's going to appear to be wider. And then that -1 on the X is going to move the entire graph to the right 1. On E, we have a negative, so that negative is going to cause us to be flipping and opening downward now. That -7 is going to move us to the right 7, and that +6 is going to move us up 6. Then on F here, the 2 is going to make it twice as tall, so it's going to appear to be more narrow. The +3 will actually move us to the left here because it's really a minus and -3. And then the -8 will move us down 8. So there we go. So hopefully we were able to kind of get that. Once you kind of get those general rules, it's fairly easy to get a good idea of what the graph should look like just from looking at the equation like that. Okay, so on 32, we're going to try and graph these without making a table. So now that you kind of know what these should look like, go ahead and try and graph those. And so I'll let you guys pause and then come back here. Okay, so what our first one here should look like, it's our base parabola, and then we move it to the right 7 and then down 2. So it's still going to keep that same shape. So your vertex is now over at +7, -2. The vertex is what's called our locator point. It's the point which we kind of typically use to kind of shift before we draw it to kind of figure out where it's going to be at its new location. And then on B, we're going to be moved to the left 3 and then up 1. That's where our vertex is going to be now. And that 0.5 is going to take the typical graph and then kind of flatten it, make it half as tall. All right, now let's take a look at number 33. So in graphing form, which is the form we've kind of been using right now, that's the form that looks like this. We got the a and then the x minus h in parentheses to the second plus k. That's a really awesome form for graphing. That's why we call it graphing form, right? So the a tells us about the stretch factor. The h and k will tell us horizontal and vertical shifts respectively. So really, really nice, and that's the majority of the info which you care about for trying to graph those. Now, standard form is probably the form you first and more commonly have seen parabolas in. That's the ax squared plus bx plus c form. So the problem there is a, b, and c don't directly tell us, hey, here's the stretch factor, here's where the vertex is going to end up being, right? So what you want to try and do is go through a, b, and c and try and answer those questions. Well, where could you find those in this particular problem? So let's pause the video, answer those, then come back here. Okay, so the orientation. So we can tell, hey, is it going up or is it going down? Because of the value in front. If this is going to be positive, we're going to always be going up. If it's negative, it's going to flip us to now going down. So that A is the same kind of A as we're seeing here. And really, we use the same variable because of that, right? That's going to be equivalent. And that kind of answers our next factor here with our stretch factor. Here is going to be 2. So down twice as tall. Now the B and C, those are different variables, so those are not going to correlate directly to what H and K are. So in C, they kind of try and walk you through a process of how could I figure that out. So the easiest way to do it is kind of what they're guiding you through there with the I, the double I, and the triple I. You want to find the x-intercepts of the parabola. So that means you're going to solve for it or factor it. If you factor the problem, you're going to get those two binomials. Those binomials will tell you the x-intercepts. And since every parabola graph, if I pull up Desmos to kind of make this a little bit more visible, every parabola is symmetric about some line. I'm going to go ahead and hide that and just show you if I do x equals 0, right? So that red line is the axis of symmetry. If I had my blue graph moved down 5, right? Or we'll do 4 to make it pretty. Okay, so I have my x-intercepts at -2 and +2, right? The vertex has to be on the axis of symmetry, which is dead in the middle of those 2 points. So I know it has to be between -2 and 2, has to be on my x being 0 line. And then to find the y value, I can just plug in the x value and get, hey, y is -4. Now if I have one that's at a different point, so like, let's say it's over here, and we'll do there. Okay, so here I'm seeing I have intercepts at 1 and 3. Again, I could factor that, find those two as my intercepts, and then say, well, what's in the middle of 1 and 3? Well, it's 2. So my vertex has to be with an x value of 2, and then I could plug in the x value of 2 and get a y value of -1 there. So graphically, that's what's kind of happening. That's not really a commonly used tactic, because it's a little bit wonky, but it does work. What we're eventually going to do is figure out how we can just change every standard form problem into a graphing form problem, because that makes it a lot easier for us to find the vertex there, but that is one method. All right, with that, let's take a look at the closure. So what strategies did your team find with for graphing equations in standard form? So the big one is if you find those intercepts, those are 2 key points, and then you can find the vertex by going right in the middle of those, then plugging that x value in to find its corresponding y. Once you have the vertex and those 2 intercepts, that's really all the points you need to get a decent estimate for what the graph is. The only downside of that is if it doesn't have intercepts, or it's really hard to factor, it's not as easy to kind of graph that. So that's kind of the downside of the non-graphing form. Okay, so with that, that is it for 2, 1, and 3. So here is our homework. I will talk to you guys next time.